Hi, my name is Ruben Bouadine, and this is my part for the high dive recording. And I'm going to be talking about a brief description of the problem. So, in this unit problem, our goal is to perform a stunt and calculate the time exactly when the diver will be dropped into a cart from a Ferris wheel that is turning at the same time the cart is moving. Here are some knows and needs to knows. So, for the knows, we have the platform is parallel to the ground from the Ferris wheel. They use a dummy before using a real life person. This is good because obviously if we use a person without knowing what we're doing, we could harm someone. Another no is that a slight error in the timing could leave the diver in splat or a splash kind of outcome. Splat being hitting the ground, splash being hitting the water. The tub of water is on a moving cart, and that was along the track on the plane at the Ferris wheel. So we know, if we go to my notes, that there's a cart on the same plane as the Ferris wheel, and there will be a time where he is dropped, and our goal is to simply get it in the same time so that he ends up safe. So for this problem, me and my group have assumed that the time which he falls has to line up with the cart in order to prevent a worst case scenario for the diver, and to ultimately achieve our goal. And that we would eventually be able to calculate exactly when the most optimum time to drop the diver and have him land in the cart will be. Thank you.
Hi, I'm Sayan, and I was talking about the different equations we found and how those equations helps us find the unit problem. So, one of the equations we found is the driver's platform speed around the wheel, and the angular speed is 9, which you can see right here. The center's height is 65, the radius is 50, and the height is, this is the height, the h and t. So this is the equation, is 50 sine 9t plus 65. And this equation helped us find the actual height of the Ferris wheel. As you can see right here, it helps us find it when we used it down here, and we found that it was 111.52 feet, and that is when the car is at negative 1754, which the negative means that it's to the left, and if you plug in, it takes for the car and driver to meet after the driver passes the 3 o'clock position from the ground in the feet. And the car's x horizontal is 15. It's right here. It's 15 w plus square root 50 sine 9w plus 57 minus 240 equals 16, and we used that, and that helped us find the function for the horizontal exponent of the car, which is what I said, in negative 1754 to the left of the center. If you plug in the time the wheel is turning, it will give you the falling time of the diver when the passes through a position of the ground the feet. So the 50 right here is like I said, the radius, the 9 is angular speed, the 50. The 65, the 57 is the center of the ground, and you divide it by 60 because that gives us that's the gravity time, and the diver's horizontal x coordinate is 50 cosine 9w, and this is right here, and that helps us find the function of the diver's horizontal x coordinate, which is 12.28 when the cart is at negative 1754 to the left of the center. If you plug in the time diver is on the Ferris wheel, for the w would give the horizontal x coordinate. The 50 is the radius, the 9 is angular speed, and the w is the time the diver is on the Ferris wheel, and the cart's traveling time is 50. This is the 50. 50 is the radius, as you can see right here. The 9 is the angular speed. 57 is actual height, and 16 and the square root is the amount of time it will take to reach the ground.
Hi, my name is Monica. So we're gonna go right into solving for the final location of the cart. So first off is the time at which we should drop the diver. And for the equation, we just put the cart's horizontal x-coordinate equal to the diver's horizontal x-coordinate. and we found it to be 12.283 seconds after he passes the 3 o'clock position. And so in order to find the time the diver will be in the air after released, we have to plug in the 12.283 into the falling time equation, and that gave us 2.55 seconds in the air. And for the total time the cart needs to travel, we again also plugged in the 12.283 into this equation, and we got that the time would be 17.55 seconds to the left of the center of the Ferris wheel. That's how much the cart would move.
Hi, my name is Marlene, and we're going to be talking about the height of the diver when he's released. So the way you get the height of the diver when he's released, it's you use the number that we used before, which is the 12.283 seconds from when he passes the 3 o'clock position. And that gives us his height when we put it into the height of the diver equation, and that's 11.82 feet off the ground. And then to find the horizontal location of where the diver should land, we use the 50 cosine times 17.55, which is the number that we got over here for the total time the cart needs to travel, and that's the final cart's location. But we use that number in this equation to find the final location, which is 46.34, which is negative, but we can turn it into a positive just by figuring out, or just by looking at the location of the Ferris wheel. So it's just 46.34 feet to the left of the center of the Ferris wheel. And that's also the final location of the cart. Thank you.